every type of rogue object in space. Space is complicated. We make it simple. Not everything in the universe belongs to something. Most planets orbit a star. Most stars belong to a galaxy. Most galaxies belong to a cluster. But every category on this list is an object that at some point got cut loose, ejected, orphaned, or simply formed with nothing to belong to in the first place, and is now drifting through spacebound to absolutely nothing at all. We're going in order from the smallest rogue objects to the most massive, then we'll sort them a second way by how they actually became untethered. Because on this list, alone and abandoned turn out to be two very different stories. Rogue planets. We begin with the most numerous category on this list, and also one of the strangest to confirm, because a planet with no star to reflect light off of is, by definition, almost invisible. A rogue planet is a planetary mass object that drifts through space unbound to any star, either ejected from its original solar system by gravitational interactions with a larger sibling planet, or, in some cases, having formed independently in a collapsing cloud of gas and dust, too small to ignite as a star at all. Here's the fact that should genuinely bother you. Astronomers now estimate, based on gravitational microlensing surveys, that rogue planets may actually outnumber the stars they were born around. Some estimates suggest there could be billions of rogue Jupiter mass objects in the Milky Way alone, wandering permanently through the dark between star systems, completely unlit by anything except the faint residual heat left over from their own formation. Here's the part that lingers. Without a parent star, a rogue planet's surface temperature drops to somewhere near the ambient cold of deep space itself, a few degrees above absolute zero, meaning any liquid water would require intense internal geological heating just to exist at all. And yet some models suggest a rogue planet with a thick enough hydrogen atmosphere, or an ocean insulated beneath a frozen crust warmed from below, could theoretically remain just barely habitable, drifting alone through interstellar darkness with no sun to ever rise on it. Rogue moons. Here's the twist. Even moons, ordinarily the most tightly bound objects in any solar system, can end up cut loose entirely. When a rogue planet is ejected from its star system by a violent gravitational encounter, any moons it happens to be carrying at the time can go one of two ways. Either they get ripped away entirely during the ejection event, becoming rogue objects of their own, unbound to the planet or the star, or they survive the ejection still gravitationally attached to their rogue planet, meaning an entire miniature planet moon system can be flung together into permanent interstellar exile as a package. Here's the fact that should genuinely unsettle you. A moon torn free during this kind of ejection would experience an abrupt, catastrophic loss of tidal heating, the gravitational flexing that keeps moons like Jupiter's Europa geologically active and possibly liquid beneath the surface, meaning a rogue moon that was potentially habitable while still orbiting its planet could freeze solid within a relatively short cosmic time frame after being cast into the dark alone. No confirmed rogue moon has ever been directly detected. They would be even fainter and harder to find than rogue planets, but their existence is considered a near certain statistical consequence of how common violent planetary ejections appear to be. Rogue asteroids and interstellar objects. Here's the reframe. Some rogue objects aren't native to our solar system at all. They're visitors, passing through from somewhere else in the galaxy entirely, on a trajectory that will never bring them back. In 2017, astronomers detected the first confirmed interstellar object, an elongated reddish body named Oumuamua, moving on a hyperbolic trajectory too fast to be gravitationally bound to the sun, meaning it had arrived from another star system entirely and was already on its way back out, never to return. Here's the fact that should genuinely bother you. Oumuamua's exact shape, composition, and even a small, unexplained acceleration as it left the solar system generated genuine scientific debate for years, including serious papers exploring whether it could be an unusually structured natural object or, far more speculatively, an artificial one, a debate that was never fully resolved before the object became too faint and distant to study any further. A second confirmed interstellar visitor, Comet 2I Borisov, was detected in 2019, behaving far more like an ordinary comet and offering less mystery but stronger confirmation that interstellar objects regularly pass through our solar system, just rarely close enough or bright enough for us to notice. Here's the part that lingers. Astronomers now estimate that interstellar objects pass through the inner solar system far more often than these two rare detections suggest. We've simply only recently built the survey telescopes sensitive enough to catch them at all, meaning humanity likely missed centuries of these fleeting cosmic visitors before we ever had the equipment to notice a single one going past. Rogue stars. Here's the pivot. If planets can be ejected from their solar systems, entire stars can be ejected from their galaxies, and the physics that does it is even more violent. A hypervelocity star is a star traveling fast enough to completely escape a galaxy's gravitational pull, typically the result of a close encounter with the supermassive black hole at a galaxy's center. In one proposed mechanism, a binary pair of stars wanders too close to the black hole, and the immense gravitational forces fling one star away at extreme speed while capturing its former companion into a tight orbit around the black hole permanently. Here's the fact that should genuinely bother you. Some confirmed hypervelocity stars are moving fast enough, over 1,000 kilometers per second, that they will eventually leave the Milky Way entirely, drifting alone through the vast, empty space between galaxies for the rest of their existence, never to be gravitationally recaptured by anything again. Here's the part that lingers. A star ejected this way carries no planets with it in most scenarios, since the same violent gravitational encounter that flings the star free would typically strip away or destroy any orbiting worlds first, meaning a rogue star drifting through intergalactic space is very likely traveling utterly alone, without a single planet, moon, or companion of any kind, for the remainder of its multi-billion-year lifespan. Rogue black holes. Here's the fact that reframes how unsettling alone can get. Black holes, too, can be violently ejected from the galaxies that formed them, and the mechanism behind it is one of the strangest confirmed processes in astrophysics. When two black holes merge, the resulting gravitational waves aren't always released symmetrically in every direction. If the merger is sufficiently lopsided, the newly formed black hole can receive a powerful recoil kick, called gravitational wave recoil, launching it away from the site of the merger at speeds potentially exceeding several thousand kilometers per second, fast enough to escape its host galaxy entirely. Here's the fact that should genuinely bother you. A handful of candidate rogue supermassive black holes have already been identified, observed at the right quasar-like objects with an unusual velocity offset from their apparent host galaxy, exactly consistent with having been kicked out relatively recently in cosmic terms. Here's the part that lingers. An invisible black hole, having already consumed or lost the surrounding material that would normally make it detectable, drifting through intergalactic space with no host galaxy at all, would be one of the most genuinely undetectable objects in the entire universe. Massive, gravitationally real, and completely dark, with no light of its own, and once far enough from any galaxy, potentially nothing nearby left for it to even illuminate by disturbing. Rogue comets and ejected Oort Cloud objects. Here's the fact that brings this category back to our own cosmic backyard. Our solar system carries its own private supply of future rogue objects, waiting at its outer edge for the right nudge. The Oort Cloud, a vast spherical shell of icy debris, believed to surround the solar system out to roughly a light year from the sun, is only loosely held in place by the sun's distant, weakening gravity at that range, loosely enough that a passing star, or even the gentle, cumulative gravitational pull of the Milky Way's own disk, can occasionally tug an object free entirely, sending it drifting outward into true interstellar space, rather than falling in toward the sun. Here's the fact that should genuinely bother you. Computer simulations of solar system formation suggest the sun likely ejected the vast majority of the icy bodies it originally formed with, meaning the objects currently orbiting in the Oort cloud today are only a small remaining fraction of what once existed there, with the rest already scattered into interstellar space over the past 4.5 billion years, indistinguishable by now from any other rogue object drifting between the stars. Here's the part that lingers. Some of the interstellar objects passing through other star systems right now, detected by whatever alien equivalent of a survey telescope might be watching, could well be former Oort Cloud comets that started right here in our own solar system before drifting off billions of years ago on a one-way trip with no destination at all. Rogue globular clusters and stripped stellar streams. Here's the fact that closes this list on a different scale entirely. Sometimes it isn't a single object that goes rogue, but an entire ancient community of tens of thousands of stars all at once. Globular clusters are dense, spherical collections of some of the oldest stars in a galaxy, typically orbiting within or around their home galaxy's outer halo. But galactic collisions and close gravitational encounters can strip a cluster loose entirely, sending the whole intact group of stars drifting as a single gravitationally self-bound unit through intergalactic space, no longer belonging to any larger galaxy at all. In more extreme cases, the tidal forces of a close galactic encounter don't just eject a cluster intact, they stretch it into a long, thin ribbon of stars called a tidal stream, visible in some galaxies as a faint trail marking the path of a smaller companion galaxy or cluster that got torn apart during a previous close pass. Here's the part that lingers. Astronomers have mapped several such stellar streams surrounding the Milky Way itself, faint trails of stars that used to belong to smaller satellite galaxies. Our own galaxy has slowly consumed and shredded over billions of years, meaning some of the stars in our own night sky may not have originally formed as part of the Milky Way at all, but were captured, stretched, and absorbed from a smaller galaxy that no longer exists as anything other than a faint streak of orphaned stars. Let's sort these 7 again, a different way, not by size, but by how each one actually became untethered. On the violently ejected end, rogue moons and rogue stars, both flung loose by close, catastrophic gravitational encounters with something far more massive than themselves. On the recoil-kicked end, rogue black holes, the only entry on this list ejected not by a close encounter with another object, but by the lopsided physics of their own formation event. On the tidally shredded end, rogue globular clusters and stellar streams, entire communities of stars, torn loose gradually over repeated close passes, rather than in a single violent event. On the independently formed end, some rogue planets, which may never have belonged to a star system at all, forming alone from a collapsing cloud too small to become a star. And on the simply passing through end, interstellar objects like Oumuamua, never bound to our solar system in the first place, using it only as a brief waypoint on a much longer journey between stars. It's worth understanding before we close just how genuinely difficult every single object on this list is to actually find, because that difficulty shapes almost everything we currently know and don't know about this category as a whole. Rogue planets and rogue moons are detected almost exclusively through gravitational microlensing, a technique that relies on a rogue object happening to pass directly between Earth and a distant background star at exactly the right moment, briefly bending and brightening that star's light in a way no other phenomenon quite replicates. A one-time, unrepeatable event for any given object, meaning astronomers can confirm a rogue planet existed on a specific night without ever being able to look at it again afterward. Here's the fact that should genuinely bother you. This means our current census of rogue objects is built almost entirely from statistics and probability, extrapolated from a relatively small number of confirmed one-time detections, rather than from any kind of complete, ongoing catalog the way we track planets orbiting stars. Every number in this video describing billions of rogue planets is a careful estimate, not a head count, because the objects themselves are, by their very nature as things that belong to nothing, almost designed to never be seen twice. Here's the last thing worth sitting with. Every category on this list started out belonging to something, a solar system, a galaxy, a cluster of companions, and ended up permanently alone, drifting through a darkness, with no sun to warm it, no galaxy to call home, and in most cases, no realistic chance of ever being gravitationally recaptured by anything again. The universe doesn't just contain things that belong somewhere. It's actively, continuously producing things that don't, and most of them are already out there right now, completely invisible and completely alone. Not bad for stick figures on a rock.